We've got another faulty Amiga to look at this week. It's this 1200, but something a little bit different because this board is shorted. So yeah, a dead short between VCC or 5 volt and ground. So this board belongs to Honest Gamer from Twitter. He got in touch with me over on X, just looking for a little bit of advice. He did reach out to a couple of other creators as well, but I was the first one to offer to take a look at it for him, so here it is. As you can see, this board was previously recapped by Retro Passion back in 2021, and at that time they fitted all these lovely new polymer capacitors. So Honest Gamer had been using his 1200 here, happily since then, running it with a new PSU, a newly built one that he got from Electroware, when suddenly the magic smoke appeared. Now I have had a close look over everything on the top of the board here, and there isn't really any signs of damage. When we turn to the bottom side though, well, we've problems there and there. Up here at the power connector we can see damage to this trace. The copper there has burnt right through and it's been blown off the board. The 5 volt comes into the power connector at this point, runs down that trace, through this filter and into the board. Now there is a capacitor there which sits between 5 volt and ground, but we can very quickly rule that out. There is no short across that capacitor. The problem must be elsewhere. Over at the CPU slot, the other bit of damage is just here. This pin has been lifted as well, and the board underneath it is charred. It's all the odd numbers on the bottom of the board here. So if that is 149, then that one has to be 47, 45, 43, 41, 39. And looking up the pinout of the CPU slot, number 139, that is a ground. With the board flipped back over to the top side, you can sort of see the damage just there, where the board has been cooked a bit. And directly opposite, pin 139 on the bottom, is 140 on this side, and that is 5 volt. So I would hazard a guess, when it's shorted, this is where it happened. 5 volts from the top of the board here has somehow been shorted to that ground on the bottom. It has drew an excessive amount of current through the board at that time. And the trace up here by the power connector, it has let go. It has burnt through. So I have been assured by Honest Gamer that this just spontaneously happened. So let's just take him for his namesake. But when it did let go, it hasn't just blown out the trace and burnt the board here. It has obviously shorted something else on the board. So we need to try and find that. It is going to be a little bit like looking for a needle in a haystack. The most likely culprit is going to be a capacitor. So let's try and isolate all the caps on this board that sit between 5 volt and ground. The easiest place to start will be all these new caps, all the new polymer ones. Interestingly, having a quick look on Google about those caps, I've never worked with them before, but from what I can tell, the failure state of these is to short. So it may well be the case that one of these has gone bad. Now they're not that old, so why would they have gone bad? In fact, why would any of the caps gone bad, be it one of the polymers or one of the ceramics? Well, Honest Gamer thinks it might have been the power supply itself. The thing that I'm most worried about, to be honest here, is that when power supplies go bad, they have this tendency to put their voltage rails high. As I understand, the power supply that he has no overcurrent protection in it. So if that power supply has went bad, that 5 volt rail could have jumped up to God knows what. 12 volts, 15 volts, could have jumped up to anything. That in itself may have fried a component. That may be the cause of the short. And if that is the case, we could be looking at significant damage to this board. But let's not get too carried away. Let's try to isolate where the problem is. Hopefully it will just be a capacitor. We'll start with the polymers as I said, and we'll start with the through holes The only two capacitors that sit between 5 volt and ground, the only two through-hole ones, are these two. So let's pull them out and see if those are shorted. Oh, the joys of desoldering through-hole components on an Amiga motherboard. You can actually see when Retro Passion fitted these, they've obviously had some difficulty getting the heat into this board. Let's see if we can't get these off. I have mixed a little bit of my leaded solder into that. This stuff has a slightly lower melting point. I'm not sure what type of solder they would have used when fitting the new caps. Yeah, that is not clearing that. I may have to walk these out. The problem with that being we don't really have a lot of room to work with. And I do want to be careful here because the plan is, if these caps aren't damaged, to just reuse them. Because, you know, they really aren't that old. That's that one out. And that's the other one out. So is our short gone? We can just measure between the points where we removed one of the caps. And no. It was unlikely to be those, wasn't it? Yeah, they are both fine. So next up then will be the surface mount cans, these things. Which of these sit between 5 volt and ground? Our board here, by the way, is a revision 1A, one of the very earliest A1200s. In fact, it's a full size board. You can see both of the 9-pin connectors for the mouse and the joystick. Both of those are on the PCB. In most later A1200s, this section here is cut off. That is a separate PCB, and there's a little ribbon runs. In fact, it runs to that point. There's the connector for it, or where the connector would be. But certainly it is nice to see a Rev 1A here on the bench, and it looks like it must have been assembled by Wang computers. I'm pretty sure there's a joke in there somewhere. But the reason I bring that up is that the layout of the caps on this will differ slightly from what's on PCB Explorer, and it's that which I'm using to try and determine where everything is. But hopefully it won't be too different. So I'm just going to go around with the Sharpie here and mark all of the caps, which, as I say, sit between 5 volt and ground. That is one of them there, for example. And do you know what, actually? I think that's the only one. No, it's not. And it's one of those things that is different between this revision and the later revisions. That capacitor there, on the later revisions, that is replaced with a tantalum. On this board though, it is a 100 microfarad. I think that says 100 on the top of it. And if I'm right, that one sits between 5 volt and ground. I suppose an easy way to test is to see if it's shorted across it. Yep, it is. Let's take that one off as well. So just those two. And the way I'm going to try and get these off is to use 2 soldering irons, because again, if there's nothing wrong with these, I just want to put them back on. If we used hot air to try and remove them, which is my normal method of removing the surface mount caps when we're doing a recap, well, using the hot air I think ultimately would damage them. We want to try and get them off without any damage. So I'll just try and do this one on the camera. Let's see if this comes off. There we are. Well, both of them are removed. Does that resolve the short? No. And to be perfectly honest with you, I didn't really think it would. Because I think, or more accurately, I hope, what has actually shorted on here is one of the ceramics. But we can use a slightly different method to find that. Because we're going to hook this up to my bench power supply, we'll force some power into the board. Current limited, of course, and I maybe set it to 100 milliamps to start. But the idea being We force that current into the board and the power should be dissipated as heat on whichever component is shorted. We just need to find whatever's getting hot. Now, the way you see this done most often nowadays is to use a thermal camera. In fact, it was only a couple of weeks ago that Rob Smith over on his YouTube channel, he had a 1200 that was shorted and he ended up using a thermal camera to find the faulty shorted ceramic capacitor.
And back to the thermal image, I've overlaid the motherboard image again to help. Wow, that lit up like a light bulb. I haven't even speeded this up.
Rob repaired his 1200 over 2 videos. I've linked them in the description of this video, make sure you go and check them out. But for the purposes of this one and getting it finished, well, I don't have a thermal camera, and as handy as it would be to get one, they are hideously expensive, hundreds of pounds. And over the years that I've been doing this, this is probably the first instance that I really could have used one, so not so much a worthwhile investment for me, certainly not at this stage. Rather, we're going to try and do it a slightly different way. Yes, I could just go around with my finger, but then again, I might burn myself, and I don't really want to do that. So what we're going to try and do first is we'll power up the board, and then I'm going to spray contact cleaner on it. This stuff is non-conductive. You could also use IPA, but this will just be handy because this is in a spray tin. We'll spray this on it and see where it evaporates the quickest. The component that's getting hot should force this to evaporate quickly. And so let's give it a go. I've attached red and black wires over here, just to where the 5V comes in and to the ground. Those will hook up to our bench power supply. But just before we do power this on, this point here, just to stop that potentially moving and shorting to something else, I'm going to put a bit of Captain tape on it. If we can repair the board, we will come back and fix that properly. So we'll turn this thing down to 3V output. And the current, I want to turn that down to 100 milliamp to start with. Output on, and it is pushing 100 milliamp into the board, but is anything getting hot? So not much point in watching this next section really, because while the bench power supply is outputting 100 milliamp, it's only outputting that at 0.02 of a volt. The bottom display on the power supply there, that is the wattage output, the actual power output. It's reading all zeros because in reality the board at this moment is only drawing 2/1000ths of a watt. That is nowhere near enough to get anything hot. It's time for plan B. And plan B is going to be the needle in a haystack approach. The only other thing that I can think of doing is remove all the ceramics that sit between 5V and ground until we find whichever one it is that has shorted. You can see here that I did increase the voltage to 5, the amps to 5 amps in total, but even with that like that, well, you can see this power supply goes into a current limiting mode. So it is outputting 5 amps, but only at 0.42 of a volt, which works out to be about 2 watts of power into the board, and nothing is hot. Nothing gets hot to the touch. So I can't really think of anything else to do other than do a bit of soldering. C801. Does that fix it? Nope. Not that one. No. C5B, this is the last one. I have checked every other ceramic on the board and none of them are shorted. It's not a ceramic. So where is the short then? Because it's not in a capacitor. See this filter? I've been looking over the board trying to see any evidence of anything else that might be a bit suspect. And this thing here, I'm not sure if it will come across on camera or not, but the coating on the wire that's coiled around this, it's heavily pitted on this side. Wouldn't it be hilarious if the short was in that? And I've just spent all this time taking off quite a few capacitors. I would dare say probably about 70. Well, there it is off the board. And looking at it more closely now, yeah, there is quite bad pitting on those coils. It almost looks as if they have overheated, which I'm sure they did when the thing went short. But is this the cause of it? Is this shorted? It's shorted. That's the problem. It's that. So yeah, our short is now gone. In fact, between VCC and ground, there is now about 200 ohms, which is probably correct. Now I wish I had looked at this more closely in the beginning. Question is though, where am I going to get a replacement one of those? I can get one off this scrap A500 board. So we'll put that in there. I'll refit those other capacitors and then we'll put some power through this and see what it's doing. We do though need to fix this before we can power it on. So not much point in keeping that bit. And I think all I'll do here is get a leg of a resistor or something and make it off from that post down to there. Just like that. So just before we do try and power this up, let's be 100% sure that the short is gone. And okay, it's reading about 80 ohms there, and that's fine. Why has that came down from the 200 that we seen earlier? I don't really know. Other than the fact that we've now fitted the remainder of the missing caps and fitted the filter. So let's connect some power. We do need to put in some ROMs. Now I'm not going to use the ROMs that came in the board, and only because Honest Gamer had only just created these. He's not even sure if these work. So just to rule that out, I'll go with a spare set of 3.1 ROMs that I have here. 391773, that goes into the bottom socket. 774 goes into the top socket. Here we go. Okay, getting a video signal, and the speakers did go pop, but just a black screen. Now the 1200 will sit on a black screen for a while, and especially here since we don't have a floppy drive connected. But maybe Kickstart should have came up by now. Well, nothing's getting hot. A little bit of heat in the CPU, but I mean nothing's getting worryingly hot. But just a black screen. There's a pin misaligned on this ROM. That one. How did that happen? Let's try that again, shall we? And be a little more careful putting it in the socket this time. All the pins are definitely incorrect now. Let's try that again. Yeah, that looks better because there was a little flicker on the screen. Come on. Come on, do something. Oh, there it is. 3.1 ROM, and it seems to be working. So let's hook this up and we'll try Amiga test kit. Should boot a lot quicker now with the floppy drive there. Or should boot a bit quicker, maybe. Come on. There we are. And the floppy drive's trying to seek, so let's give it a disk. Yeah, that side of it seems to work. So it is correctly detecting our O20 processor and the fact that it's an AGA machine. Memory, 2 MB total detected. That's those. Let's do a test. Yeah, it's been run a couple of times there. That's fine. Don't have the keyboard connected. The floppy drive, well, it booted. I make a test kit, so let's assume that's okay. Controller port, that's alright. Left and right, that's working. Yep, that's all fine. Audio. Yeah, that sounds fine. Low pass filter. Yeah, I can hear that working. Yeah, working fine. Video, oh, looks okay, and yeah, looks fine. CIA and chipset, that's all okay. Real-time clock, we don't have one of those. Serial and parallel, well, I don't have the dongles. I will have to build them one of these days. But everything else tests fine, so let's just assume that they're fine as well. Only thing left to do then is to try and repair that lifted pin on the bottom of the CPU slot. So we need to glue that back down. And for that I'm going to use some 2-part epoxy. But I just can't squidgy that on there. Rather, I need to make a bit of a channel for this to sit in. So it's time to use the Dremel. I have this thing set as slow as it can go. And we're just taking out just the tiniest bit of the PCB here. Then need to mix up some of this. Now granted, that is way too much of this stuff. All we need is the tiniest of coating on that. In fact, I think I'll use the tip of my knife to try and put this on. And then let's just fold that back down. Oh shit, it broke off. Oh, I was hoping I was going to get away with that, but it's broke off. I think that would have worked if that hadn't broke off. And I'm just going to leave it like this. But the fact that it did break off, anything I'm going to do there, I think ultimately it's just going to hamper the connectivity. But you can see as I'm going at that with the cotton bud there, it's not catching on anything. So that is fine. That should not peel back any further. And it is just a ground. And there is plenty more of them. Well, that's it sorted. The short is now gone. If only I had noticed the pitting on that coil earlier, it might have saved me a few hours work. But sure, that's all good soldering practice, isn't it? And at least the board is fixed now. But it has claimed one more victim. And unfortunately, it is my TF1260. And I think this answers how the CPU slot got damaged in the first place. You see, the board had a square edge on it. I have since chamfered it, but I tried fitting my 1260 to test with before doing the chamfering, and unfortunately it has pushed some of the pins in there. It has pushed them up flat. They may actually be shorting out to the pins on the other side. Maybe that's how the board got shorted in the first place. Not sure, to be honest. But I do now need to get a new connector here for this card. 1200 is running fine though. After I chamfered the edge of it, the TF1230 is now in it and it's working grand. And I have tested Honest Gamer's ROMs. Those are fine as well, although this is 3.2 point something. The hard drive I have on the 1200 at the minute only has a basic version of 3.1 installed, so it won't work with these ROMs. But that's it for now. I'll get the board boxed up and get it back to Honest Gamer. But if you enjoyed this video, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.